right, so in this video, I'm going to show you how to find the degree and leading coefficient of a polynomial. But first, let's just review the parts of an expression. So over here, we can see that we have some statements here. So an expression is a number sentence without any equal signs. So something along the lines of what we see here, 4x minus 7. So there's no equal signs. Each part of an expression is called a term. The variable is a symbol that we use. So we often use a letter for our variables. But honestly, you can use any symbol you would like. The coefficient is the number with the variable, so a number that's in front of it being multiplied by it. And the constant is the number without any variable. So it's the number that's not being multiplied. It's all by itself. I know what this number is. It's just -7. Remember that negative belongs to the 7. This one is not just 4. It's 4 times x because they're together. I know there's a little space here, but that was just for the diagram. All right, so now we're going to go through and we're going to label the parts of the expression here. So the first part of the expression, this part is pointing at this x, which we just went over, and this part up above here, that's called our variable. Variable. So that's just called a variable, and it can be any letter, A through Z. There are certain letters I would probably stay away from, like the letter O because it looks like zeros. The lowercase l can look like a 1. Just, certain things to kind of stay away from, but really can be any symbol you would like it to be. I've even used the @ symbol in class before just to have the point, or sometimes I even use question mark because why not? I could just have a question mark there. It's 4 times something. What is that something? So it's just a placeholder. That's all a variable is. And then this little arrow here is pointing at our minus sign here. This is what we call an operator. So it's just telling us what to do with these two terms. I'm going to subtract them. Okay? And then we can see that the two arrows are coming here and they're pointing at these circles. And what they're pointing out is that we have terms. So we have 2 terms. So these are what we call the terms. And then this arrow here is pointing at the 4. So this is our coefficient. Which is just the number in front of a variable. It's what's being multiplied. And then the constant, that is our number without a variable. So I already know it's 7. It's not being multiplied by anything. It's not going to change. It is -7. Now, I can combine it once I know what x is, but it's not being multiplied or divided. All right, terms are separated by addition or subtraction. So that's how I know that these are different terms. 4x minus 7. That minus sign separates the two terms. Okay. Expressions can be identified by their number of terms or their nomial. Because when we hear nomial, like polynomial, nomial means number of terms. Okay. So types of polynomials. So poly actually means many. And nomial mean number of terms. So many number of terms. Okay, that's literally what polynomial means. And down here, so we have these ones here for this example. We have x or 3y or 46. Sorry, I was going to say 4x, but 46. They're separated by commas, so they're different pieces, so they're all individual. So these are all just one thing. There's no addition, there's no subtraction. So these are what we call one term. Okay? Remember, nomial means how many terms, and one, when I want to say that, it's monomial. So M-O, monomial. And then we see this example here. I have x squared plus x or y plus 3. So now I do have an addition piece here. So I have 1, 2 terms or 1, 2 terms. So this is 2 terms. So 2 terms is binomial. And then in this last example, I have x squared plus 2x plus 19. So there's only one example here, and I have plus, plus. There's no commas. This is all just one. So I have 1, 2, 3 terms. Oops, the R didn't quite go there. So that's a trinomial. Now, of course, we can keep going. There's more than just, 1, 2, or 3 terms, but this is pretty common. These are the ones that we tend to use. Expressions can also be identified by the highest exponent of any one term, and that's called its degree. So that's what we're going to do in the next couple problems. We're going to identify its degree. The leading coefficient is the number multiplied by the variable with the highest exponent. Okay, so that's quite literally what we're going to do on the next couple of pages here. We're just going to go through and let me get this open on my side here. And we're going to determine the degree, and then we're going to determine the leading coefficient. So we have a couple practice problems here, and I give you a hint. I say put the terms in order using exponents. So what I mean by that is identify the largest exponent. So I have an 8, that's the largest one, so I'm going to go negative 9v to the 8th power. The next one would be 6. The next one would be 5, like this, and then plus 7v. So now I have them in order from from greatest to least using exponents. So now that I have them in order, it's very, very easy for me to determine what the degree is, because the degree is that largest exponent. So the degree would be 8 in this one. And then the leading coefficient is the number that's being multiplied by the variable with the largest coefficient. So this would be negative 9. And then we can, try another one here because we have 2 examples. So now I'm going to do the same thing. I'm going to put them in order. So 8, so negative, whoops, put in that 8 a little too low, like that. Plus, the next one would be 2, 5y squared. This one, even though I don't see one here, there's a 1. So if we don't see it there, it's assumed that it's a 1. A lot of the time, we even see things like this where I don't see a 1 in front of the y, but it is 1y. We just don't put the 1s there. They're assumed to be there. So that's the next one. And then the last thing would be just that constant number that does not have a y. So now I can go through and do that exact same thing that I just did on the last one, is just identify, and by chance this one has the exact same degree. So I just grab that largest exponent and the leading coefficient. On this one, it looks like just a negative, but remember, there's a 1 there. So it's really, whoops, negative 1 for my leading coefficient. All right, so that is how you identify the degree and leading coefficient of a polynomial. So go ahead and jump on Alex and give it a try.